Can able to see my screen? Yeah, we'll start the session now. So yesterday we speak about the evolution of cloud data warehouse and how the Snowflake is how the Snowflake is come into picture of the cloud platform developed, and we talk more about different systems which are available in the market, like for cloud data warehouse. What are the different system and what is the difference between the traditional warehouse versus cloud data warehouse, and what is SaaS service, how it differs uh, with the traditional warehouse. And then we discussed on few of the topics related to use cases of Snowflake and what is data engineering, how Snowflake is used as, like, how Snowflake supports for the data engineering, and if you are selected for data Snowflake developer, what are the roles you have to do in the company. And also we discussed about the course details in detail, uh, and also we discussed on the syllabus, course syllabus. So we'll also discuss on the course syllabus as well as today end of the session we'll discuss. And today we'll, as we understand, like Snowflake is the cloud data warehouse, right? It delivers as SaaS, software service. That means you no need to install anything on your computer. So once you get the Snowflake account, so everything can be taken care by the Snowflake team. So that's what you need to understand. So we'll discuss today on topic like how this Snowflake architecture developed. So this is very important, right? So as we are working in the cloud, so without understanding the backend, how the how it is designed, so it's like it's very like it won't be perfect, right? So we'll understand how the Snowflake cloud platform are designed. So basically, Snowflake is multi-layer cloud platform. So which is basically contains a three layers on it. So one is database layer, other one is query processing layer, one more is cloud services. So we'll start with the cloud database storage, and then we'll go into top. So then we'll discuss on this topic. So here it is. So database storage layer. So stores the table data and query results in this particular third-party cloud service storage providers. So we have majorly three, right, in the market, which provides the GCP as well, which provides the cloud storage to any particular service, which is that's the one majorly used platform is AWS S3 bucket, and one more is Azure Blob and GCP. So these three services which offers the storage, cloud storage. The Snowflake takes the support from these three services to store the table or query results or data like tables into this particular storage. It will take care everything once you get the Snowflake. So the storage, the Snowflake team will allot you one of the storage. So Stata is stored in columnar format and in micro partition way. So what it means? So basically our data, if you take a normal Excel, so if you take a normal Excel, we have the data in the form of a row to column format, right? So we have certain number of rows and certain number of columns on it. For suppose, like in this way, the data stored in the rows and columns the way. So the first row we will consider as headers, and then the values starts from the second row. Basically, in most of the cases, this is the structured way of any structured table. So when it's saved in, for example, if you are using, if we have the traditional warehouses nowadays, the systems not nowadays, in the like maybe before 3 years, all the systems, all the data is there in our traditional warehouses, right? Traditional warehouse in the sense MS SQL, MySQL, Oracle. Those data is directly saved on the physical machine, means physical computers. So that particular data is saved in the format of as it is as your raw data. If the raw data is like this, the same way your MS SQL. So it will insert the values like one row and the second row, below which third row. So like that, it will store the data. It means it's a replicate of your input data. But whereas in Snowflake, so the rows, these rows are there, right? These rows will be converted into the columns and it will save at the back end. But you will see at front end the structured way only. If you return a query and if you return a query in the Snowflake and you try to retrieve the data, but in the front end you can able to see the structured way. But in the back end, it will save the data as like this. The entire row, right? This row, entire set of row is converted into 1 John 30 USA. This row is converted into column, and then the next row is converted into column. So each set, this one, right? 1, 2, this ID. Each set is called micro-partition. And then the second set means the column, whatever the data in this column, the second set, this is called micro-partition 2. So what if there's data is saved in the format of micro-partition way, what is the advantage we will get? So for example, in the live, like in the many industries, this, like it will pull the data. So it will pull the data means it will pull all the data from the raw data. So it consists of unnecessary columns also in it. But the business users sometimes may not be like take the action like take the action to control over the columns. They want all the data to be in a warehouse. So whenever they require, they can use that particular column data. But basically, we need to insert all the raw data, whatever the columns in the raw data, we need to insert into your Snowflake table or any other cloud you are using. So in that case, what will happen? So when you're working, right? So for example, I just like when you're working in real time, so basically you no need of retrieve the data from all these columns. Basically, that is the case in most of the scenarios. So you need only few columns data to retrieve or in your query, you will use only few fields data for working. So in that case, what will happen in in traditional warehouse? So for example, I want only select name from employee table. This is let's consider this as employee table. You just called only name column, right? So the result should be like this. The result should be like this: John and Alice. This is the final results. You will get it printed. So what will happen at the back end? You are calling this query in traditional warehouse like MS SQL. So what it will do? It will go row by row. So it will search this row. Okay, this entire row it will scan and it will take this value. And then the second row, entire row it will scan and it will take this value. And then third row, if it is there, the third row, entire row, it will scan and it will take that value. So you have to understand here, like, so it is reading every record of all columns in traditional warehouse, whereas because the data is saved in this format in traditional warehouse, whereas in cloud data warehouse, what will happen? The same query, if you return and if you try to retrieve the data, so the Snowflake, as you know, as we discussed, the Snowflake will save this particular data at the backend in partition format. If it is partition, so it no need to scan all the partitions. So your select name from employee data table is available in this particular partition. It will directly go and it will fetch this particular data. It no need to scan all these values, right? So that is a big advantage. It's much more faster as compared to traditional warehouses. That's why it's the cloud data warehouse is popular because of this particular optimization they did, most advanced optimization they did before implementing this cloud data warehouse. That's what you need to understand. What is micro partition? How this? What is a like if the data is saved in columnar format, means the rows are converted into columnar. So that's why we will call it as columnar format. So if the data is stored in the columnar format in micro partition way, what is the advantage we'll get it in our day-to-day activities that you understand, right? So it is much more faster. The query results are much more faster. So it manages all aspects of how your data need to be stored, data organization and file. So this is about data storage layer, right? Yeah. So it manages all your data, how it need to be stored, what is the schema, which schema the table need to be inserted, and what is the metadata. Metadata means whenever you are fetching any kind of query, so temporarily the query results will store at the backend and temporarily. So again, you if you are working in the same table, so you are having the metadata metadata is already ready. So you need to connect to original table and again retrieve the data. So by using metadata, also you can able to get the results. So what it will do, it will directly in the second query, it will directly connect to your metadata, that temporarily stored data, and it will fetch the data. So the results are much more faster in those cases. So those can be organized by your database storage layer. And data cannot be directly visible. So once you get like for example, I'm taken this MS SQL. So here you can see all the database, the server, right? This is server under which database, under which the tables, the same structure maintained by the Snowflake. So you can able to see now only database objects, right? So what is database and tables and views, the corresponding table, like databases under which tables, views, only those names alone you can able to see, but you can't see the results of it at the front end. So that so to see the results, you need to connect, you need to write a SQL query to fetch the data. So that is the big security advantage, right? Obviously. So data cannot be directly shown to any user. So that will cause your security issues for a real time. Like if you are working in real time, that will be the big problem, right? The data cannot be shown directly. Once you fetch the data, then it will ask you for require, like if you are as a user, if you are allowed to uh, connect to that particular time, retrieve the data, only you can able to see. So that's what the database, the storage layer will do. So we can define the cluster keys on large data. Cluster key concept is like it's a used concept in SQL, but it's the basic definition is cluster key means. So in the basic definition, but anyway, I will explain in brief in during our lecture. But basic definition you need to understand, like for suppose this is the table, you have ID, name, age, country. So for suppose you are creating, you created cluster key on this particular country. So what will happen? So you return this query. Select name from employee where country equal to USA. So cluster key, what it will do basically, so it will sort the data. So based on identical values observed, because so what it will do, so USA year country and then USA again. So all these USA results, they put in one order. If you create a cluster key on particular column, it will put all this USA results in sort in particular order, and then other country. So like that. So so if you write this type of queries, so what it will do, it no need to scan all your records. So anyway, if the cluster key is there in this country column, so it will order this particular USA result, right? So it will directly fetch this USA results. So that's a big advantage when you're working in large data set. If you create a cluster key, so that can be also allowed in the database storage layer in the Snowflake. So those cluster key concept, everything we'll explain in brief in our lecture. but the basic definition you need to understand. Yeah. So query processing layer. So yeah, the like this is all about the storage layer, right? So now we will discuss on query processing layer. So now, like if you take any computer in basic, if you take any laptop or computer, you have your storage, that means your hard disk, and one more thing is your CPU or RAM. Both should be there to operate any kind of activity in your laptop. So we discussed about hard disk, means database storage layer. Now we will discuss about query processing layer, that is literally the same meaning of your CPU in your laptop. So what it will do? So now you have the data at your backend in the database storage layer. So ultimately, your goal when you're working as Snowflake developer, you need to always interact the data. You need to create a different data pipelines to, and you need to automate many of the data pipeline, and you need to do most of the data engineering work, right? For that, you need to always interact with the Snowflake tables. So obviously, while interacting, it backend, it needs to fetch the data, and it needs to connect to that particular table, and it need to show to your front end, and then you need to move to some other pipeline, like some other task in the pipeline. So those things uh, you need to do as part of data engineering, right? So those things, to do those things, you must have CPU, right? Without CPU, you can't perform those applications, because when you are opening any application in your laptop, the CPU comes into your picture. CPU in general, what it will do, it will temporarily store the data. For example, you are browsing anything, so you just open the YouTube and you are watching a video. So you are watching a video at front end, but back end, so how it is getting the data from your that particular network, and it is doing means, so it temporarily always pull the data and it will stores in your CPU. So then only you can able to fetch the data from CPU and you can see. So that's what RAM means, temporary memory, right? Once you close the application, RAM data will get erased. So that is the meaning of that. Always you are interacting with the web browser means, so the web browser data should come somewhere, right? Then only you can able to see a front end app. So without getting the data temporarily stored in some of the thing, you can't able to see at your front end. So RAM purpose is for that. So whenever you open an application, it will temporarily bring the data and it will put in your RAM, and then the data is shown to your front end. So without RAM, you can't able to browse anything. You can't able to do any activity, right? So like that, in our Snowflake, we have query processing layer. So in this, what we have to do is same like that. In your laptop, we need to create our own CPU in Snowflake. That is called virtual warehouse in Snowflake. So we need, like, it will perform the activity. So this is the actual processing unit of Snowflake. This is what you need to understand. Like your CPU in your laptop, this is the processing unit for the Snowflake. But when you purchase the laptop, you have specific CPU RAM value to it. For example, 8 GB means 8 GB only. You can scale it up and down. That if you want to upgrade to 16, so you need to do a lot of stuff. You need to go to laptop service center, and whether this laptop is compatible to enhance increase your RAM capacity, those things and all, like vast. But whereas in Snowflake virtual warehouse, you can scale them, you can add the resources more, you can degrade your resources less within a fraction of time. That's a big advantage we will get here. So why we need to increase the our resource size means, suppose when you're running a query for urgent purpose, so that query is running very late, it is taking lot of time, but the customer wants in very short time. So that means you need more processing units, right? then only you can pull the data in very faster manner. So in the Snowflake, you are once you get the Snowflake and once you allot it to some system role, you are the eligible to increase your virtual warehouse size, as well as when you are running as like when you are running some test cases, like in test cases it won't take much time. So in that case you can down your virtual warehouse size to, so downing like increasing and decreasing the virtual warehouse size will matters for your final billing of your Snowflake account. So whenever you are running any query, the Snowflake, while running, the Snowflake will charge you for certain amount of money. So based on your virtual warehouse size and processing time, based on that, the billing matters. So you are more optimized towards the billing ultimately, because you should because of your activity, the entire project should not be cost more. So for that you need to learn about billing as well as how to optimize our code. So many aspects you need to work on. So this is all about virtual warehouses. So compute cost will be calculated based on your query execution time. So you can scale up and down compute uh, so compute capacity of your virtual warehouse. So cloud service layer. So collection of all services that coordinates the activities. So next one is, so now you understand it's cloud service layer, like query processing layer is very as simple as your CPU of your laptop, where in Snowflake we will call it as virtual warehouses. So different virtual warehouses is there, right? So this is simply virtual warehouses, whereas in your laptop it is the CPU of your laptop. And then cloud service layer. So it's the brain of your Snowflake, entire Snowflake. So what it means, so like whatever activity you are performing inside Snowflake, so all the instructions will pass to cloud service layer. Then only you can allow to do a certain activity. So what it generally what it means, for suppose you just logged in a Snowflake account. For example, simple as like I just logged into here and I just connected to server name and authentication, window authentication and many things. So if I don't have, for suppose I'm just selected SQL Server authentication, it is asking for my login ID and password. For suppose if I entered wrong password, for example, I just entered somehow like something like this. So what is showing? So cannot connect to this particular server. So additional information. So this is user and password is incorrect. So how you are where this is identifying means through cloud service layer. What it will do, whatever the information you are passing through here in query processing layer and database storage, so it will pass to your cloud service layer. So it will check all your authentication and access control, whether you have proper access or not. It will check. So if you don't have proper access, it will pass a message. You these guys don't have proper access, like this message will pass. So it's a brain of your brain of your human also. It's a brain of your a woman. For suppose without like brain instruction you can't do any activity, right? So that is how it will work. So without this permission from this cloud service layer, cloud services the services which is offered, so other activities won't perform. Like it's all activities performed by cloud query processing layer and the database storage layer all depend on the instruction like from the cloud service. That's what I'm like I want to tell. So I just told by giving the example, the same way the Snowflake also will work once we get the account. Yeah, so this is all about cloud service layer, and we'll discuss more on the Snowflake features. This is very important. So anyway, once you are trying for Snowflake developer, you must understand how the Snowflake features are very advanced, how these companies are really looking for Snowflake because of these features offered by the Snowflake. So you must know what are the features offered by the Snowflake. So these are the major features which are offered by the Snowflake. One is major cloud platform support and unlimited storage and compute, software as service. So it is Snowflake is software as service, right? So virtual warehouses, supports for structured and semi-structured data, and time travel and failsafe, clone or zero copy cloning, continuous data loading supported by Stream, Snowpipe, task, which are the part of Snowflake, micro partition and data loading, data encryption and data security. So these are the features. So we'll discuss one by one in below slides. I'll just zoom the screen. Yeah. So the major cloud platform support, what it means. So as we know, the Snowflake take the storage from the cloud service provider, which are AWS, Microsoft, and Google. So it will take all the, like it will runs on all this AWS, like Microsoft Azure and cloud GCP. So you no need to worry. Like if you like the AWS consuming less cost means you can able to switch to AWS. If the Azure is consuming less cost to store your data, you can switch. So this is the advantage, right, for cost control. So Snowflake will runs on all these platforms is a big advantage, obviously. So this gives the flexibility. You can choose your preferred cloud or even deploy the Snowflake across multiple clouds. So for suppose some of the data pipeline you can deploy into cloud, AWS, and you can connect those particular data to Azure table, and then you can move. So like that, many dynamic things you can able to do. So cross cloud data sharing is also possible and making collaboration seamless. So what it means, so you can move the data across all this cloud platform independently. So enables disaster recovery and failover across cloud providers without complex setup. So what it means, so you can able to recover the data very easily because that all your data is not present in your physical system, because once any disaster happens, the physical systems will go away, right? Any for a, suppose fire accident or something happened, so the if the data is existing in a physical system, that all the hard disk everything will be damaged. But in our case, in Snowflake, all your data is in cloud, so you need to worry about the disaster recovery. We can able to extract the data very easily. And then unlimited storage and compute. What it means, Snowflake supports storage and compute, meaning they can scale independently. What it means, as we know already, the storage layer of Snowflake will be taken care by AWS, Azure, and GCP platform, and compute layer we need to create in our Snowflake. So the storage and compute are purely independent. You can scale, means you can use the AWS, you can ask the AWS service to increase your storage directly, or you can create a virtual warehouses inside the Snowflake, and you can increase the resources independently. You can store unlimited amount of data without impacting query performance. This is also very important. So you can use unlimited storage capacity. There is no limit, because you can, if the storage and compute layers are separate, right? You can ask AWS people to give more amount of memory, and they will allot you within a second, and you can put the data, huge amount of data in it. And compute power can be increased and decreased instantly, so only you can pay what you want. So that's what I discussed, compute power of your virtual warehouse here. So that can be increased or decreased based on your query, your complexity of your query. And then large analytical queries can run without slowing down a smaller operational task. This is also similar to the above one. So that's what. So the your one, like if you have multiple queries to run, you can use multiple warehouses, and you can allot to different multiple warehouses to different queries. So it won't disturb other tasks. When you're running 2-3 tasks at a time, you can allocate different virtual warehouses to different thing, so independently. So other queries, because of one query, other query might not slow down. So that way you can able to uh, optimize your query, and you can uh, make sure that your job done very fast. So eliminates capacity planning headcounts because resources expand automatically when needed. So this is very important. So capacity planning means headcount. So once you like if your physical system in olden days, the data sits in your computer. So if you want to scale your CPU up, in some cases you can't able to scale them up, so you need to purchase one more computer, like that. Some infrastructure changes you need to do. But whereas in cloud, you no need to worry. So directly when you want, directly you can create your virtual errors and you can allocate particular CPU resource to it. But whereas in traditional warehouse, you have do lot of planning, right? So then only you can able to do such kind of activities. So that is about unlimited storage and compute, and we'll discuss on data platform as service. So this is very important because this is also similar to the above. So fully managed. So this Snowflake is fully managed. No hardware, software, infrastructure maintenance. Snowflake handles all. So unified platform combines storage, compute, and secure data sharing in one service. So this is the way every software industry works. So every software industry ultimately needs work on data, right? To work on data, they need to store the data in somewhere. So uh, Snowflake allows you to do storage and combines the storage and compute. To process the data, compute also requires, and secure and data sharing. This is very important. So after doing all this activity, you need to share your particular data model or data things to end customer, right? So that sharing service also will be allowed in the Snowflake as secured way. This is very important. Without security, your data leak to some of the public, it won't be the your suddenly your company will come into blame, right? So this is very important in every cloud services, which should be take care of your data uh, very well. Means data security offered by the any cloud service provider should be very strict manner. Elastic and scalable. So instantly scale your compute, as we discussed, and storage independently. Pay only what you use. So multi-cloud and secure this one. So runs on all these cloud providers with built encryption and compliance. What it means? So even Snowflake people, encryption means even Snowflake people can't able to see your data. So that what is that meaning? So and compliance. So the Snowflake is handles your data, means they can able to see your data, but if your data is encrypted means they can't able to see your data. So all your Snowflake tables data is fully encrypted, so that no other people except your company people can see your data. So virtual warehouses. So this is a big concept. Like, say virtual warehouse is complete cluster of your running queries. So as we discussed right before, you can have multiple warehouses for different teams running queries without affecting each other. So as I told, right, you can create many number of virtual warehouses for different teams. So they can run your their queries in their virtual warehouse. So other teams cannot be affected. So warehouses can be paused when not used and save the cost. So this is very important because whenever your query executing only, the warehouse will come into active and it will do the particular job. But without running query, the Snowflake team should not cost you, right? So that's what it will do. It's cost effective. The Snowflake cloud data warehouse is cost effective because of many reasons. This is the one of the reason. And support structured and semi-structured data. So this is very important because most of the times in 80% 80 to 90% you will work in structured data, means rows to column format. But in some of the cases, if the data from your web app or some of the APIs, the data should not be, it won't be in tabular format. It will be like semi-structured way, like JSON file if you see. So in semi-structured file also can be handled in the Snowflake. You can able to clean up them very easily by simple Snowflake commands in the Snowflake, and you can put them in structured table. So that can be performed in the Snowflake. It can support structured and semi-structured data. So time travel and fail safe. So this is the unique feature of your Snowflake. So this is no data cloud data warehouse offered. So what it means in general, in our traditional warehouse, if you see, this is a traditional warehouse, let's say MS SQL, right? So I'm writing a query. Select, I'm just retrieving the data, all the data from that. So this is the data. So for suppose one of the requirement, they all ask you to delete employee ID 3. Where employee ID equal to 3, they want to delete this particular record. So just you did this activity in MS SQL. So what it did, it just deleted the record. So now if you want to fetch this data, the 3, employee 3 is gone. In traditional warehouse, you can't able to retrieve it back. The whole table. The whole table data consists of employee 3 also, right? That information, once the data, one record getting deleted, until and unless you use the try catch block, you can't able to retrieve the data. So, but whereas in Snowflake, so that kind of drawback is revised. Means you can able to retrieve the data within 90 days of time. So Snowflake team will take care. Once you put the time travel feature on that particular table, so you can able to, you have the rights to retrieve the data within 90 days of your um, uh, 90 days of your working. So if you take enterprise version, most of the companies will use the enterprise version. So in this version, like in this edition of your Snowflake account, you can able to eligible for to retrieve the data. You can go back to 90 days and you can pull the old data. What is old data? What is the data available at that time? So that can be done here, and require accidentally deleted out and updated data. So that's what I explained before, right? So fail safe. So extra fail safe means, so for suppose if you are exceeding 90 days, even though if you are exceeding 90 days, the Snowflake team can hold your data after 90 days. 7 days it can store, it can hold your data. So after 9 days of expiry, the Snowflake team can hold your data till 7 days. So within 7 days, if you want any like a disaster recovery or some of the time travel expiry expires, right? So that time you can approach them within 7 days, they can able to recover your data and they can give. So that's the big advantage. So clone and zero copy cloning. So this is very important. So cloning means it's duplicating of your table. For suppose if you're working in some kind of testing scenario, so where you want to do some of the validation check on your particular table, for example employee table. So when you're doing, you have to do some lot of SQL, like you need to alter some of the data in this particular table. So that time what you do, what you used to do in general, you will back up this table. I mean, means you will duplicate this table in somewhere in this database, and then you will work on the duplicate table or original table, whatever you want. You will work on that. So it will consume the data, it will consume the storage for your duplicate table as well as your original table, right? Obviously. But whereas in Snowflake, so if you are duplicating any table, it won't consume the storage for your duplicated table. So it will just clone the table in such a way that it will capture that particular data and it will literally, it don't consume any storage in your cloud. So you don't need to pay for that. So that is a big advantage, right? So the cloning, how it will clone, why it is not take any storage for duplicate table, that I will explain in brief. I will cover up in our regular classes. So as of now, you need to understand is the cloning won't consume any storage in the Snowflake. Save the storage space and time. So useful for testing, development, analytics, or on production data. So this is a very useful cases. And continuous data loading by using streams and snowpipe. So streams and snowpipe concept I will explain while designing any data pipeline in the Snowflake. But you need to understand like how the data continuously loading into our Snowflake tables by using streams and snowpipe. The snowpipe automatically loads the data from cloud storages as soon as it arrives. It's a fully automated data pipeline. So once the new data arrives in an AWS or Azure block or GCP, immediately the data pipeline will trigger and it will pull the data, latest data, and it will put the data in your Snowflake table once you create any data pipeline by using Snowflake. And then streams. Track changes means insert updates and deletes in any particular table, right? So that time, so you can easily the updated data or inserted data will immediately load into your external table directly. So you always get the what is original data till the date, because it's fully automated data pipeline by using Snowpipe and streams. So micro partition and data loading, right? As I already explained you, what is micro partition, how the data is saved in micro partition. So what is the use of saving the data in the micro partition way? So the same way here, data is stored in columnar format inside micro partition. So each micro partition is automatically indexed and optimized for query performance. So eliminates the need of manual indexing and tuning. So everything in brief I'll explain in our lecture, but you just like you understand the basic definition as of now, right? That is enough for now. Now the final part is data encryption and security. So this is every cloud service layer should maintain. So your data should not be read by even the Snowflake people and outsiders of any other competitor of your company. So data can be viewed to the business users and employees in the company only. So for that, so it should offer the Snowflake offer end-to-end encryption. Data is encrypted in transit and at rest. So it can't be seen by any of the people except company people, and supports role-based access. So once you get the Snowflake account, you will be having multiple roles. So based on role, you have to do your activity, and some of the standard cloud standards also the Snowflake reached. Yeah. So this is all about the Snowflake design and the Snowflake features. So we'll discuss on our uh, training syllabus. Just a minute. So yeah, this is our training overall syllabus of our training. So we'll start with introduction and setup of your Snowflake, because as we know, the Snowflake is the cloud, uh, data warehouse, cloud data warehouse, right? It offers a service. So you must take the free trial account and to work on Snowflake. So that I will explain everything, how to do self-registration and free trial setup here. And then we'll start with the architecture and interface in brief in this topic, and then core components. core components and object management. Here I will cover the SQL basics and different core components and objects are available in Snowflake. Everything I will cover here. And then here data loading and batch loading, batch and continuous loading. There are two techniques, batch and continuous loading. So those techniques, by using simple Snowflake commands, how we can set the continuous loading, we'll discuss here. And also here itself I'll discuss the basics of AWS. In most of our lecture I will use AWS S3 bucket. So I will discuss on basics of AWS as well in this particular lecture. So performance optimization, this is also very important. When you're writing any SQL query, you must know, or if you are designing any data pipeline, you must know how to optimize my query or data pipeline. So this is the general question in most of the interviews they will ask. And data time travel and data cloning. So this is the unique feature of Snowflake, right? As we discussed. So how to set your time travel and data cloning. So everything I'll explain here. And then secure data sharing and access control. So after which how to share your data to end user and what are the access roles in the Snowflake. Everything will cover here. And streams, task and detail automation. This is a important topic. So there are variety of techniques which are available in Snowflake. So everything will cover up here. And then advanced development and views. So this is the one of the topic where you can we'll discuss on procedures, views and cluster keys, materialized views. Everything we'll discuss here. And finally, we have monitoring, building and cost control. This is also very important because without knowing this, when you're doing when you're selected for data Snowflake developer job, like you must know these particular things, because uh, to work on very decent way, means your query should not cause more cost to your company, right? So you need to understand how the monitoring, building and cost control takes place in the Snowflake. And we have one end-to-end Snowflake project implementation, real-time project. This is a real-time project. It includes all the services which are offered by the Snowflake. So after this project, you are ready to get a job. I will support. Will also support for your resume preparation and interview support as well after this training. So this is all about the syllabus and the Snowflake demo. So if you guys have any questions, you can ask me. You can feel free to ask me. I'll stop my screen. Yeah, if you guys have any questions, you can ask me. No problem. Yeah, hope you guys don't have any questions. We'll meet you again in our next lecture. Okay, guys. Thanks for joining.